All right, we are live. So, good evening, everyone, and a very warm welcome to each and every one of you to today's Skill It Up workshop, right? And a little extra warm welcome to the people living in the northern part of India because it is getting so cold up here, right? Can I get a yes in the comments if I am clearly audible to everyone? Can you type a yes in the comments if I am audible to you? All right. All right, great. We're good to go. So, moving on, over the next 1 hour, you will all be learning about what system design is, what it is all about, and what all you need to do, what basics do you need to practice to learn, and most importantly, the why of it, right? The why do you need to learn system design, right? Or why is it important to learn about system design interview questions, right? And to help you guide through it, we have a very special guest with us today, Mr. Ashish Day, who is currently working with Microsoft as a STE and who has previously worked at Amazon too, right? So we have managed to bring in an industry expert for you today who has a lot of experience. So please pay close attention to everyone that he has to say. Please play close attention to everything he has to say today and utilize this opportunity to the fullest that you have today, right? So again, before bringing Ashish on, we also have a very special announcement for all our uh, live viewers. We have a very special surprise planned for you today, right? But I will only tell you about it after Mr. Ashish is done with his lesson today. So please, I request everyone to attend the full workshop today, and not only for the surprise, but also for a chance at getting some great insights about system design, right? So without wasting any more time, I would like to call on Mr. Ashish. Hey Ashish, how are you?
Hey Raghav, thanks for this amazing introduction. I'm really awesome. Yeah, great to see you all. And it's really amazing to be here in Geeks for Geeks live webinar. It's like really amazing and fun to be here. So let's see
Yeah.
like how exactly I can deliver the best out of it.
Yeah, we are sure you'll do a great job, and we are excited for you to be here today too, right? So, first of all, I can see some sunlight on you, and I can tell you, being here in Delhi, that you're really lucky you're getting that, man. I
Yeah,
mean,
Hyderabad is amazing, man. The weather is really awesome. So it's like every day is almost the same, whether it's winter or summer. Summer are a little bit hot, but
all right.
I cannot like bear cold.
All right, good for you, good for you. So, again, before you begin with your presentation, I have a short question for you that I want you to answer so
Hmm?
that our live audience can get an overview of what to expect over the next hour, right?
Right.
Uh, is the topic, our today's topic, system design question? Is this, would you suggest this to college students or to working professionals or both? That who should attend this workshop today, in your opinion?
Right. So it's mostly for the working professional with having like
Right.
at least 1.5 to 2 years, but it's also good for college students as well because like let's say at some point of time you are certainly like going to be in that level, right? And preparing for system design it's not easy. It takes a lot of time. So if you are like preparing from now, certainly like by the time like 1.5 to 2 years you are at that stage like to go to the next level, right? So it will give
Right.
you a lot of boost,
All
right?
right, great, great. Thank you for informing our viewers about that. So again, everyone, Ashish has had a great workshop planned for you today. So please don't miss any moment of it. And I will see you all at the end of the workshop, right? So Ashish, the stage is all yours.
Great. Thanks, Raghav. Okay, let's get started. Okay. hello everyone, the viewers over here. It's great to be here, like the live webinar. So this session today we are going to have is a system design. It's not like a particular question that we are going to discuss. Uh, like a particular discussion if you're going to do, that's not going to help you in the interview, right? The question can be anything. So over here, like we'll see like what are the tips and tricks, like how exactly to perform well in the system design interview. What are the expectations for from a like interviewee perspective, like what you should present as a part of system design, and if there is any question which is like completely unknown to you, how exactly you should like approach the problem, right? So what happens to us like whenever we are seeing a system design and it's like completely unknown to us, we like no, we are completely stuck, like how exactly we are going to actually approach this problem, from where to start. This is completely descriptive, right? Okay, so like let's see like how exactly, and I have like a lot of things planned for you today. uh, so yeah, so this is about like the boring part, the agenda. I hope like it's not that boring. Maybe like it will excite you. So as a part of agenda, so we'll see like whys and hows. Like a lot of companies they ask like, okay, Facebook or like design or Twitter, but why they ask like what exactly the expectation is from that, right? And if you get such kind of problem, then how exactly you are going to deal with that? So we'll see like whys and hows. We'll see like expectations, like what they expect out of you. Like, is it like you be a leader, or is it like you work with the interviewer to come up to a solution? How exactly, like what are the expectations? We'll see like common mistakes that we generally make, and that actually completely screws up our system design interview. And we'll see the recommended system design template. Like this is like really important. System design template, why this is really important is it's for any kind of a system, right? It's really hard to figure out each and every component, but the flow, if you like stick to a particular like a flow, so then it will help me like, okay, this is the point I am starting and this is the point I'll have to reach, right? So this is a recommended template only. It's not like that it is the final template. You can modify it, it's up to you. And also you can add some of the things like whichever you feel like are really good. So it's up to you. We'll see like components of a system. This is again a generic, like you can use this entire components to meaning like design a lot of different kind of systems. So it will have like, I'll show you like it will have a lot of systems. So you just pick some of the systems. If you want to design a Facebook, if you want to design Twitter, maybe like you'll pick some another components. If you want to design, let's say like tiny URL, maybe like some of the components you'll pick out of it. So I try to make it like generic so that this may help you in your interview. We'll see how to apply the learnings that we have to design a Facebook. So it's not going to be like entire end-to-end Facebook design, but we'll see like how exactly we can apply. The reason is like in the interest of time, it's we cannot like design this entire Facebook, right? Okay, and bonus, this is the bonus, like how a Facebook interview looks like. So I hope like this will excite you. Okay, so let's jump in. This is a bomb. Okay, hi, what is this? I don't know, like, what is this? What is this, right? So this is like, so scary kind of a system. Is it like this kind of system I have to like design? This looks so scary. Will I be able to like even design such kind of system? Yes, you will be if you'll follow like a similar kind of a pattern. Certainly, these are like pretty easy. In fact, if I compare with the algorithms, like problem solving interviews and the system design, I find like way more easy. Why is that? Is like it's kind of a not active study is required for this. If you know the fundamentals, then any kind of system design you can certainly like come up and design a system. It's not like that, okay, tomorrow you have an interview a week after. It's not required that you should be very much actively studying about system design. If you know the components, certainly like you can design a system very easily. So that's the beauty of the system design interview. So why now, like why the companies ask such a big question? Like Twitter, if I'm talking about Twitter, they'll give me 45 minutes and they'll say, okay, design Twitter. is it like possible? Like I have never like worked on Twitter. Like I don't even know like what Twitter looks like, the internal system, right? Then why actually they are asking such kind of question? It's about your curiosity for the technology. They want to know like, okay, whether you are curious to understand, know the technology better or not. So either maybe like from your company tech talks, it may be through internet or it may be through friends, discussion with colleagues. Like, did you like ever paid attention to understand any kind of a system, right? So that's what actually they want to know, whether you are really curious for the technology or not. So that's the sole purpose of it, why they ask such question. Because in general, whatever that we work is like in a small piece, right? It's not like we have completely built one Twitter entirely. In fact, Twitter engineers also, they have not built that entire Twitter like single-handedly, right? So that's why like you should understand a lot of systems and then apply your like learnings to design like a different system. So that's why like they want to ask you, uh, then how? Okay, they asked me like, okay, design Twitter or design Facebook. Then how should I like approach? Is it like I don't have a knowledge, like okay, I don't know like how Twitter internally looks like? So it's not like that. You have to know how it has been designed. It's like how you are going to design. So that is about how. It's like you are the architect. It's not like that how the architect of the Twitter has designed it. It's like you are the architect and I am the, like if I am taking your interview, I am the interviewer. I want to see you how exactly you're coming up with the approach. So you, as in the industry, like maybe like expert in particular domain, but if you have paid attention to a lot of different things through the tech talks and all, you have like a lot of knowledge, right? You just pick some of the things from there and create a design. Like it's not like that it should be a completely workable design, but it's a viable design. Okay, this can work. That is how exactly you should focus on. Okay, I know, okay, how a load balancer works, I know how a cache works, I know how application host works, I know. So these all things you'll have to put together, and that is how actually you will create a design, right? And a quick tip over here, never expect uh, already asked question, or like you should not expect that whatever you have studied, that question is going to come for you. Always expect for a surprise. And that is how exactly you will be ready for any kind of system design, because it's not like kind of an algorithm that there is a straightforward solution for it. It's very much descriptive. You just keep on adding stuffs, and it will be, keep on like getting better and better. So like expectation, let's see like what they are expecting. Drive the conversation. Why is that like drive the conversation? As system design interviews are not for the beginners. These are for the experienced people, right? So if you are not driving the conversation, means you are not behaving like a leader. So you have to like lead the conversation. So I generally say one phrase like lead or lose. So if you are not able to lead the interview, you already lost the game there. So that's how actually they want to see whether you can be a leader or not. Because as a experienced guy, you're going into that industry, and there what you are going to do is like you will maybe like leading the juniors, right? So that's how actually you should act as a leader. So this is one expectation. Now you are given completely vague problem. How exactly you are starting like small? Okay, maybe like if you are asked like a Facebook design, it's not like you will be talking about, okay, I have a billion users and I am starting to design my system like this. No, it doesn't work like that. So it's like you have to start small. Let's say for there is only two users are there. Okay, two users are there. Then how exactly my system look like? Okay, this is how exactly, okay, my solution is working for two users. Okay, let's scale it up. So that is how you start small and slowly keep on adding users and keep on adding like whatever as a part of scalability is required, and you reach to a viable solution. So that's how actually is the expectations from the interviewee. This is the third is like really important, and especially if I talking about like a FAANGs, this is really important. Whenever you make any decision, you have to be like very clear like why actually you are taking this decision. Meaning, let's say you want to choose SQL over NoSQL. It may be like you want to use some cache, but why actually you want, you should be like very very clear like when you are taking a decision, right? So if you are not able to like clearly explain, then that point is like that is going to be in a negative direction. So you talk about both. For example, if you want to choose like NoSQL, you talk about SQL also, like what is the problem there, what is the benefit that you are getting in a SQL, and then actually you are making this choice. In fact, like for if some kind of a algorithm inside a microservice that you're designing, you are choosing, there also, do you have any other choice for any algorithm, different algorithm? Then you compare and then only come up to a solution. It's not like directly you have found a solution somewhere, okay, and go to the interview. Okay, I'm going to use NoSQL here, but why? I don't know, because but I will use this. So that way things does not work. So be aware, like you should discuss the trade-offs between whatever the decision that you are making. It should be your design. This is like again like very important. In most of the FAANG's interview, that is what actually you will see is like the interviewer will be sitting completely idle, or like he will just watch you, that how exactly you are approaching towards the solution. If you are expecting like a lot of hints from the interviewer, be sure that it's not going to be your design. It's like half your design, half his design, right? So it has to be your design. That is how actually the expectation. Uh, Try to cover both breadth and depth. This like again very confusing, right? Breadth and also depth. How exactly like this may look like. Just like a little bit confusing, right? So then what does this mean? So breadth means we all know, like we should know about a lot of systems. But what about like for all system, do we need to know like the depth also? If I would say like yes, but not for all systems. It's about like for what are the systems that you design, there is a some part which we call as a core logic that has to be discussed during the interview. If you are not discussing that core logic in depth, meaning like you are not able to explain the design properly. For example, if there is a design for a tiny URL, the core logic is how actually you will generate a unique URL for each long URL that you are getting. If I are talking about Facebook design, you the core logic you must discuss is how actually you're generating the feeds for the users, like how actually like in very short or quick time, how they are like you are able to generate the wall like feeds of the users. Like Facebook, if you are logging into Facebook, it takes like hardly milliseconds and it loads your entire feed, which are coming from a lot of different users, right? So that is the core. And if you are talking about Twitter trends, like how exactly you are processing your hashtags to come up or calculate the Twitter trends. So that is like a depth of what the discussion. So, and breadth is about you are knowing a lot of systems, be it like a load balancer, be it a cache, application host, or be it like some kind of streaming service, or be it a logging, or like whatever, like a lot of things that you should be knowing. That's about breadth. So this is again, we're talking like get signal on both your technical and communication skills. So over here, like be sure communication is not about English or like whichever language that you're talking about. Communication is about whatever is in your head. Are you able to clearly deliver it or not? So that's about communication. So whenever you are speaking, be sure that it is reaching to the interviewer. And if you are really like figuring out, okay, you are thinking the interviewer is not able to understand, and that's why like it's always recommended to stop between maybe like each 7 to 10 minutes and ask some questions. Do you have any questions over here, or was I not able to clearly explain this? So that kind of like pause we always take during the system design. So and technical is obviously is like whatever the learnings that you have, whether from your company, either from internet, or from wherever it is. Are you like technically sound or not? Whatever the decisions that you're making, are you like really a technical guy? You're making the decision with like a lot of thoughts or not? So that's what is one more like very important in expectations from the interview. So yeah, that's about like expectations. See, like this is now the most important part, how actually you are going to approach any system design interview, right? So that's how I come up with like some kind of a template. I already mentioned that it's not like a fixed template, it's like a recommended template. It's up to you. If you would like to add some of the things over here, like it's up to you, you can add over here, right? So the very first thing, you are given one line statement: design maybe tiny URL, design Facebook, design Twitter. These are like one line problem statement, but we do not know how exactly. So the very first thing we should do is what that system is, what this system is going to do, what are the functionality it is going to have. So that comes as a part of a requirement gathering. So if I am talking about like a tiny URL, if interviewer is telling, it may happen that he meant like completely different from that statement. It may be like something different for him. So we'll have to clarify whether he meant the exactly the same, that the long URL has to be converted to the short URL, or is it like something else. So you'll have to decide. And okay, let's say like, okay, interviewer said, okay, you'll have to convert the long URL to the short URL. Now these are not, you should not expect that interviewer is going to tell you, okay, these are the requirements. You should as an architect think about, like, for this particular system, what are the best functionalities that I could give to the user. So that's how actually you should think from the user perspective. So for tiny URL, it may be like, okay, I should be able to create the short URL, and then again redirection, like from the short URL I should be able to redirect to the long URL. And then we'll have like maybe like some custom URL we may apply, like, okay, so for google.com I'm sending, you give me a custom URL which namely G4G. And some like other is like, are we allowing any expiry of the URLs that we are saving? Are we allowing users to delete? So like a lot of functionality that can be, you think through it, note it down, and then work with the interviewer. Okay, these are the requirements that I am talking. Do you want to add some more functionalities over here, or should I remove any of the functionality? That way, like, okay, you are very much clear about the requirements. But over here, two things over here. These are, we talked about the functional requirements, and then comes the non-functional requirement, which comes as a part. We can say like, which comes as a bonus when you are designing the system. It's not like, okay, these are directly helping the users, but they are indirectly helping the user. So we'll discuss more about like what non-functional requirement is and how they look like. So now the estimations, most people think like, okay, estimations are not so important, but these are not like that. Estimations are really important. It shows you that how exactly you are able to ship your product. Ship meaning like when you are building a product, you have to ship in the market, right? And you do not know like how many users they are going to be. So that's how actually you have to estimate like these many users are going to be, and based on that, how many machines that you are going to put, how many instances of the databases that you are going to spawn, what are like the bandwidth requirement for it. So that kind of estimations is very crucial. If you are skipping this, certainly like you are going to be to get negative points for it. So be sure to do estimations. But as a part of estimation, I recommend three things mostly. One is like the in data, that how much data that is coming in to our system. Second is like out data. Out data is like how much data that is going out from our system. And third is a QPS. So the QPS, when we talk about QPS, but QPS for what? There may be like a lot of functionality that you are providing. For example, for Facebook, you are providing functionality for send friend request. There may be like likes, there may be like comments, and there may be like, okay, loading the feeds. There may be writing post. There are a lot of things out there, but QPS, when you're talking about, be specific. Okay, I'm talking about the QPS of the feed loading API, or like I am talking about the QPS of making a post. So that's how, or like maybe you can talk about based on read and write also, that like a write QPS is this and read QPS is this. So that's how for estimations you have three things: the in data, the data that is coming into our system, how much data, and out data, like how much data that is going out of our system. meaning like whenever we are pulling the feed, so the data is coming out of the system, right? And the third is a QPS. So the third is high level design. So this is a the backbone of the entire system design. That's what I say is the backbone. Once your high level design is ready, so at that point of time you'll figure out, okay, you have these components. You can clearly see, okay, these are the components that I have. Now I'll have to pick one component after another and I'll have to discuss each component, right? So once you are able to create this high level design, then be sure that you are already like more than halfway through, like mostly like 70% you are already done. Because when you are able to see each component, you will just pick one component and you will discuss that. And it's always easy to discuss one component than like too many components altogether, right? So that's how actually, so give some time in creating the high level design, invest some time, and be sure your high level design represent most of the components that you are going to use as a part of your system design. uh, yeah, so now is a deep dive looking into each component. That's what I said, like whenever you have the high level design ready, you can pick one system after another and you can do a deep dive on it. Now there comes the core of the problem. What actually I say the core of a problem, as I already discussed, like for each system you have a core logic that has to be discussed. Like for Facebook, it is how you are going to quickly calculate the feeds of the user. For Twitter trends, how exactly you are able to calculate the trends. And for TinyURL, how actually you are uniquely generating the short URL. And maybe for different kind of a system, you can have like a different core problem, but for each system you be sure like you will be having at least one core problem which has to be discussed. So invest some time over there and discuss like in and out everything out of it, and be sure to discuss it in so much of detail. And because this is going to build everything for your this entire system design. This is going to give you like a lot of positive points. Here actually you are going to make a lot of decisions, right? Okay, you are choosing this system or choosing that system, choosing this algorithm. So discuss over it. Like that's why like you invest at least 7 minutes on it. Scalability. So now once your system is working for like very less number of users, like 2 users or 3 users or 4 users, and then how exactly you are going to scale. So that's how actually is a part of scalability. So you discuss like, and scalability is when you talk about scalability, it's not like a scaling at some at a specific layer. When we talk about scalability, if you will start comes from the like load balancer, it may be like load of users, then there also you need to scale. You have the application layer, there also you need to scale. You have the data layer, you have the cache layer. So as a part of scalability, be sure to discuss on each layers, starting from the load balancer to the application layer or to the data layer and to the cache layer and whatever the other microservice if you are designing, okay, you may need to scale. Then be sure like you discuss the scalability on each layer. And then you should discuss the partition and fault tolerance. So it's like if a system goes down or if a system is not behaving, not healthy, then in that case, how actually you are routing the request to some other system, or maybe like if some system goes down, how actually you are putting a new system without impacting users. And if a system you are adding, it should not impact any existing users or the data that you are having. If your cache goes down, then how exactly you are going to handle it. If your database goes down, then how exactly you are giving us the users the reliability that okay, your data is not lost. So that's about like a partition and fault tolerance. So be sure to discuss at the end about it, like okay, at every point you your system is so robust that if anything goes down, then your system is able to handle that. So these are like some optional things. Security, like very important, but optional for most of the system design. If there is any specific ask, you can discuss about security, like authentication, how actually you're authenticating users, how actually you're authorizing users. So some of the things that you can discuss, and it adds some positive points. So it's up to you if you are going to discuss some kind of security. It's optional. There's logging that also is, again, I said like optional. And then why I said is optional is as a part of logging, uh, it's not like you'll have to discuss, okay, these are the things that I am going to log. But if you are able to discuss and you are able to cover in 45 minutes, be sure like cover that. But system design is a like huge discussion, and it's very hard to even discuss the logging. So metrics and dashboards, this again gives you the exposure that actually, okay, interviewer may exactly like figure out, okay, this guy has certainly like worked on some features. That's why like he's aware of like metrics and dashboards, how exactly to create these. So if you have good idea, be sure to discuss, and this is certainly going to bag you positive points. So that's how the template looks like. You have like a lot of 10 points, which looks pretty massive, right? So, but till 7 is certainly like you have to discuss. Try to follow. It's a like a recommended template. You may come up with some extra things. It's up to you. And you may remove if you, but I don't think like anything that you can remove over here. So yeah, this is a component design diagram. This looks really scary, but this is really helpful as well. I actually personally try to generalize the any kind of a system that we design. For like a lot of videos or a lot of tutorials that we'll see that for every system design, what they do is like they're creating some kind of a specific diagram for each, right? But when we'll come up with like, let's say 50 design problems, and you are seeing such kind of tutorials, it will completely confuse you like where actually to use, right? But the expectation of interview is completely different. It's like you are working with your fundamentals, and you are putting the components, and you are coming with your design, right? It is like you are the architect. So that's how actually one, the components, be sure like to try to put those components in the right place, and your design will automatically be ready. It's not like that you'll have to learn and you'll have to mug up from somewhere. So these are actually some of the system components that I have drawn, which may help you. So I'll discuss like each and everything in detail, like what actually these are. Uh, so yeah, I, I'll have to give me 1 minute. Yeah. So over here, like as a client, certainly like the request is going to be from the client, right? So as a client, it's making a request. So where it is going is a load balancer. So this load balancer, some people like to write is an API gateway or like a reverse proxy. It's up to you. There is a quite a lot of overlap between the load balancer, reverse proxy, and API gateway. So it's fine like you write whatever the name that you want to give, but certainly like over here there will be a load balancer. In fact, reverse proxy can be implemented to have a load balancer inside it. API gateway also like can be configured to have a load balancer inside it. So I am explicitly showing over here as a load balancer, so that to show like, okay, this is for balancing the load. Now then the request comes. So this is like a front end that we say is a front end layer. It's like a very thin layer. Meaning it doesn't do a lot of things. It doesn't do any kind of calculations for the users. What it does is like it verifies like few things it can be having is authentication, authorization. Like, okay, this user is making, whether this guy is authentic users or not, whether the token or whatever this guy is passing are like these are valid or not. It can do some kind of rate limiting. Let's say some bots are attacking your system, then how exactly you're going to stop? So that's how like it can contain some kind of rate limiters. Okay, stop this guy. This guy is making a lot of requests. This may bring my system down. So it can have some kind of a rate limiter. So which is over here, and the authorization service is over here. Authentication and authorization service is over here. So this is it. Like it's a like very thin layer. Then the request goes. These are is like application host. So these mostly try to keep them stateless. Why is that? Like it it's like, if you want to scale, it becomes easy for you if they are stateless. So yeah, for some people it may be like making like stateless, and a lot of things that I'm talking may not make much sense. But uh, this if you like when you are hearing these terms, like if you'll dig deeper, these are not like too much difficult things. These are like pretty easy things. Like it will take like maybe like an hour for studying about one component. So go and invest some time if you are like these terms looks like completely unknown to you. So what we are doing is, this is like one layer. What I'm saying is, this is a application layer where like these each application host, these are stateless, and they are, the request is getting routed to any of the application hosts. And so so this is the application host components. You can put n number of application hosts based on your scalability requirement. Then there comes the logger. So this is what this logger is. This is a global logging system. What does this mean is, the global logging system is meaning like any of the microservice that you have, any of the other service that you have, everyone is going to use this logger. So this logging system, for any company that you'll see, they have some kind of a centralized logger. So which every service is used, and those data goes to a particular location. Now, going forward, like so application host, when the request reaches this application host, they may make some kind of logs over here, and over here, like it may ask the data from the cache layer, or if it is not found, then it will go all the way to get the data from the database. So this entirely I am like showing in like very generic term. It's not like a particular design. What is this is again like a message queue, or like a streaming service. So if you have like a very high scale, you are getting a lot of requests, and the stream of requests are coming in. It's very hard to process in the runtime. Okay, like the millions of requests that you're coming in, okay, per second. Then how exactly you are going to handle that? You cannot process them in runtime. So what we are going to do is, we are going to push those events which are coming in into some kind of a streaming service, or like if there are like some limited kind of a messages that we want to process, then you can put a message queue over here. And there is a some aggregator. What it does is, it keeps polling from here to get the data, and it will fetch those data, it will do some kind of processing, and then it will push that into the cache, and also push that into the data store. So these are the systems, and we have like few more. Is one is a cleaner. What is like, if there are something I have to clean from the data store, like some data has expired, so as a part of that, we need some kind of cleaning. And we have a session manager over here for maintaining the sessions of the users. So this looks like a very kind of a lot of things, but certainly like you don't need all of the things, but you will certainly need a lot of things out of it whenever you're designing any highly scalable system. So we'll try to apply how exactly we are going to apply to design a particular system. So I hope like this makes sense to you guys. What I am recommending over here is know about like some kind of a components and how exactly they interact. If you can add like more components over here, that's good. And whenever you are designing any system, you pick a certain number of components out of here, and you design a system. uh, I recommend like don't like try to create completely a different kind of a design for each system design problem. That will be very difficult for you to manage if you are reading about like 40-50 design problems. So that's how it is. So let's see like how exactly then we are going to have this design Facebook. Shall we take like some question if anyone is having? If there's any question over here, uh, and I think my light is okay. There are a lot of, give me a minute. I think I'll have to switch on the light. Yep. So There are like class level design. Some okay. When you are talking about like class level design, so someone has asked like, okay, do we need to create some kind of a class level design? So when you are designing like on a high level, like a big system, class level designs may not make sense, but when you are digging deeper into a particular component, at that point of time, it may happen that you need class level design as well. Uh, so so someone asked like, what is the core of the problem? So like for whenever like actually you are designing that any particular system, like if you are talking about Facebook, so the core you can figure out, or maybe like you can work with the interviewer that is it like something specific he is looking for. For every system, there is something specific part that has to be entirely discussed in and out of it. For Facebook, it's like how actually you're going to load the feed, that too in like a very low latency. So any query or so okay. Okay, so yeah, so maybe like we'll take more questions. So if there are any other question, when to discuss the API and DB schema, right? So DB schema comes whenever you are actually discussing the core of the problem, or like you can when you are discussing the high level. At that point of time, you have like good amount of time that okay, you created this high level and you are discussing each component, right? As a part of component, each component you will be picking the database component as well. So at that point of time, you may discuss okay how your database schemas may look like. Okay, so some more question maybe like okay, we'll take some more questions later. So let's move ahead and see like how we are using these components that we have, and how actually we are applying the template that I discussed. So let's see. So as a part, okay. Now, so as I said, like as a part of template is we should always start with a requirement, and requirement it's not like only the functional requirements, but we should also discuss the non-functional as well. So now you are given a one-liner problem is design Facebook. So what comes to our mind, right? Okay, we some may not have used Facebook, right? And they may not be completely. I totally understand. Maybe it happened, uh, but it's rare. But still, let's say it happened. Then at that point in time, like what exactly you are going to do? It's like you'll have to work with the interviewer. Okay, what a Facebook is actually? I do not know what a Facebook is, but in general, like we know Facebook, so we can think okay, these are the features that generally Facebook has. But out of those, like is it like we are going to put all the requirements? Because Facebook has a lot of things. A lot of things means ad generation, you have like a like, comment, you have post, you have a loading the feed, you have a chat, you have a like security, privacy settings, you have profile management, login system. A lot of things are there. So is it like we should start discussing all of the things? No, whichever you feel like are the really important part, you should put them as a list of functional requirement, and then you work with the interviewer is that are you looking for any specific requirement? If there is any, then certainly like the interviewer will tell you okay, I want to discuss this as well. So the first requirement, user should be able to write posts. Certainly like Facebook is built out of this post only. Like if there are no posts, Facebook cannot exist, right? So user should be able to write post, it be it a text or images. Videos are also there, but as a part of a short discussion, because you have in the interview is 45 to 50 minutes, so you can keep the scope limited. It's not like that you should start discussing okay, I will discuss about a video post, and that itself is a huge discussion. It will take like a 40-50 minutes, and then you are like not able to discuss the entire system. So this is the first requirement. Second is like user should be able to load feeds. That's like certainly like whenever we are logging in, we should be able to see like how our feeds look like, what are the posts made by our friends. So that's like very common, right? Now, user should be able to like and comment on a post. That's obvious, and one of the very critical and important feature of Facebook, right? A user should be able to write and comment on a post. then user should be able to follow someone. I have added like a follow. It's like the same sending a friend request and follow. Actually, these are like two different things in Facebook, but let's assume like both are common. Either follow or send friend request, both are same. You can work with the interviewer if he says no. Okay, follow is like a separate and friend request is completely separate. These are like very like common features. Other features that may come to your mind, okay, how to show someone as online, right? These are also important features. So that's how actually you can work with the interviewer. These are the things I am thinking. Is it like, do I need to put discuss them as well? If interviewer says okay, no need to discuss, you can create another list as a out of scope, and there you can put them as a, okay, these are out of scope. Right. So this is like a functional requirement. Now, this is like non-functional requirement are a little tricky. So it's like very hard, because what I said is these actually comes as a part, as a bonus to the users. Users do not not seeing them directly, but these are actually happening behind the scenes. So what are the non-functional requirements that we are required to have over here in the Facebook? Low latency. Why is that? When you are loading the feed and then it's taking, let's say, 2 minutes, no one is going to use your system. So that is like, it's like by design it should come for free, that okay, whenever I am logging in, the feeds are loading so quickly that like users should be happy, right? So that's a non-functional requirement. But for low latency, it's not like we are designing any special feature, so it should come from our design. High availability. Now, let's say you are writing a post. At that point of time, it's not like that you are not able to use Facebook, or like you are not able to scroll through the feed, right? So that's kind of a blocking. So meaning like it's not available for you, or like at any point of time, like the system has to be available all the time. So that's how actually we'll have to design our system, that it has to be highly available. Consistency. Let's say I made a post and you are my friend. Then is it like really required for you to see the post just after few milliseconds? It's not required, right? Even if it is landing after 2 minutes or 5 minutes, it should be fine, because no one is like dying to see my post. If for some like system design, the consistency is very important. For like in a banking system, let's say if I did a transaction of any amount like a 5,000, it has to directly reflect, right? So I went to the ATM and then I did a transaction of 5,000. It has to reflect. Otherwise, it may happen that if it takes some time, then I'll do another transaction, and that point of time it shows me a balance which has not yet been deducted, right? So, but for Facebook, it's a eventual consistency. What is eventual is after some point of time it will become consistent, meaning maybe like after 3 minutes or 5 minutes, my post you will be able to see. Reliable, like this is like again like very important. Reliable is what are the posts that we are making. Facebook should like take care of those. It's not like they are lost in the midway, right? If somehow they are lost, or like meaning like the system is not reliable, so whatever are coming in, it has to be properly stored somewhere, and a highly persistent, highly reliable data store, so that like we should not lose the user content. And then comes highly scalable. Certainly, like Facebook has 2 billion cross users. Certainly, the system that we are designing has to be highly scalable. It should serve that billion number of users, right? So it has to be highly scalable. So these are as a part of a non-functional requirement. And one more that's like a fault tolerant. And then fault tolerant, you will see like for most of the system, you will see fault tolerant means if some system goes down, it should not impact any user, or like it should not impact users data. Let's say your database goes down, then it should not happen that all the data is gone, right? So that's how is a fault tolerant. Our system should be like completely fault tolerant. If anything happens to the application host, it's fine, like it's still like it is getting served, and the users are able to like use our system. But fault tolerance and there are like quite overlap between the fault tolerant and like reliability. So it's okay, like you can put a fault tolerant as a separate requirement. So that's about like functional and non-functional requirement. Now comes the estimations. So estimations, I especially like said, there are three things to be discussed, right? One is the in data, which is the data that is coming to our system from the users. Second is the out data, the system which are going out of our system. And the third thing is the QPS. QPS is for maybe you are defining as a part of a read and write, or maybe you're defining for API. So be sure like QPS, you should not say like, okay, the QPS of Facebook is this, right? That doesn't work. So QPS of what? So you should be very careful. So estimation is like a lot of mathematics that involves. So I'm skipping that part because in the interest of time, I'm not doing that mathematics. You can assume like do the estimation based on, okay, these many users are there for Facebook. You can compare, okay, like for each day, maybe like these many users are active. And for each day, maybe like a part of users are making a post. And like and then out of those also like maybe like each user on an average are making like a 2 posts. So and you can compare, okay, like the size of each post, you can assume maybe, okay, let's say it has image, so 100 KB or 200 KB, you can make some assumption, and based on that you can estimate that how much data that is coming in per day. And you can like take a provision, okay, for 5 years how much data that we are generating. And similarly you can calculate for the read as well, like how much data that is coming out. So I'm skipping estimation in the interest of time. Let's move and see like how actually I'm using those components to build this Facebook design. So again, as I said, like we should be starting very small. Over here, like our system is very small. Like we have, let's say, there are only 2 users in Facebook. User A makes a post and user B just reads. And we'll try to fit, and then we'll see, okay, this system is working for 2 users, then we'll try to scale. So this is the high level design. Let's say we are talking about like making a post. User A comes in, okay, writes a post. It hits, okay, submit. Then it hits the load balancer. It goes to the application host. Like load balancer routes it to the right application host, which is nearest to the user, or like which is best for the user A. And then from the application host, the very first thing, as I said, is like our system has to be reliable. Without any processing, the very first thing that we should do is we should write it into the data store. Why is that? It may happen that if you are doing some processing, if somehow the system goes down, then we lost the data. So that should not happen. So we are writing that first into the persistent store so that it should remain safe. And then what we'll do is like maybe what we want is for each user, we want to process the feeds, maybe like processing the hashtags, maybe processing the content, so that like it should not have any adult content or any like content, politically motivated content, or any kind of content which is not allowed. So that you think that has to be processed. So we are passing that entire, like what are the posts that are coming in to some kind of a service. So for now we have only users. So let's say like it's like a very small service for now, because when we'll extend it, will certainly like it will be a stream, huge stream of data that is coming from the users. Now that's how actually it happened is user made the post, okay, it went to the application host, it went to the data store, and we're done. The post is saved, right? Now that post has to be visible to this guy B, right? So how this guy is, this guy logs in, okay, this guy logs in, it makes a request, okay, give me the feed, whatever the feeds, whatever the posts that I have from my friends. This guy again makes a request, it hits the load balancer, it gets routed to the any right application host. And then it may be like for the performance, we may be using some kind of a cache. So it will first try to look into the cache. Is the data there? Okay, it's there. Then return it. If it's not there, okay, talk to the data store, get the data, and then return it, right? So writing a post and reading a post, yeah, certainly like it's happening. Now over here, like you see, there are extra components that I have put. Now once we are increasing the number of users, right, at each point we'll have to scale. Certainly at this point we are going to get lot and lot of events. So that's why we need over here like some kind of a stream processor. So how exactly then this is going to look like a stream processor? So you are pushing like, okay, all the post over here, maybe like different events as well. So we need some kind of aggregator which will actually process these posts and store them into the data store. So it does some kind of processing. It keeps on polling, okay, the events which are coming in, and it does some kind of processing, maybe processing of. So it may have like a multiple microservice as well. One maybe like for processing of hashtags, another maybe like processing of adult filtering, a lot of things that can be there. And after the processing, it will store that in a data store and also maybe like push into the cache so that like it is readily available for the user, right? So aggregator, and then there is a something called feed generator, as we already discussed. Like, okay, what we want is the feed load should be very quick, right? So it has to happen like very quick, meaning certainly like we'll have to serve it from some cache. If you are going to the data store and we are trying to calculate the total number of feeds that has arrived for a particular user, a user may have like thousands of friends, right? And you will be pulling each friend and those friends posts. It's like too much of data that has to be pulled during the runtime. So it's not possible to land the data in like so much of low latency. So in that way, what you need is there is some kind of feed generation service which will readily like keep the things ready for you. Like whenever user asks, okay, give me the feed, it will just come to the host, application host. It will check the cache. Okay, my feed is ready, just return it. That's why actually in Facebook we see like it's hardly takes a few milliseconds to return the feed. Now this is actually the high level that we created. There may be like other components that you can add over here is as a part of that which I discussed is over here you can add some kind of a like a front end service, okay, for authentication, maybe like to for a user how exactly they are logging in. You may add some kind of a logging system, okay, logger system over here, which may be used by all the system, whatever the system that we have. Even this also like maybe using the logger system. So you can add some more system, but be sure whatever the system that you are adding, try to cover as much as possible. So over here is then your component design is ready, or a high level design is ready. So then in detail you'll have to discuss like this, how the feed generation is working, how the schemas and everything that are looks like in the cache, in the data store, how the schemas look like in this component. What is the work of the aggregator? You can talk if this is really important. And then then the stream, like how exactly the stream, how you are and what exactly you are storing. Now like this looks like very dirty, too much of details that I have. So now this is the actually, as I said, like once you are done with the high level design, you can see each component and you can pick each component once at a time and you can discuss more about it. So that's how actually is like the entire skeleton that we created. Then the things become easy. Like it's simple to discuss like one small component, right? So that's how actually is high level design for Facebook. And there are like a feed generation service. We are not discussing it, but the thing it does is pre-generate or pre-calculate the feeds for you, and it will be storing the data into the cache so that like any user which is coming in, then that user will directly fetch the data from the cache rather than doing calculation in the runtime, right? So yeah, that's how like okay. That's how actually it looks like till the Facebook high level design. Here, like a lot of things that you'll have to discuss each component in details. And also as a part of over here, as I mentioned already, that you have to discuss a lot of other things, which are the scalability, the partition fault tolerant, and the scalability to which I was talking in each layer. I was talking about these layers. Let's see over here. So in this layer, like how exactly load balancer, if there are a lot of users, how exactly are going to scale, maybe front end also, how exactly are going to scale, and then the this application layer, how exactly, so everything goes down, you are going to add some machines. If addition, so is it like addition of machine is impacting users, or if some system goes down, how exactly you are going to handle that is a part of fault tolerance. and how exactly you are going to scale cache, and also like from fault tolerance, how exactly you're saving it. And for database also, if something goes down, how exactly you are ensuring that the data is not lost for the users. So that's how actually a little bit about like how exactly we can apply the learnings that we had with the template that we have, that components that we learned about how to apply to design Facebook till the high level. But yes, as I said, like it needs to have like more discussion, like core is there still. You have to discuss scalability, maybe and deep dive into each component, that also you'll have to do. And partition tolerance till this 7 is certainly like really really important. And you must try to actually discuss a little bit about metrics and dashboards. That's what is my suggestion. That gives the like impression that you have certainly worked on some systems, and you have the idea of how exactly a metrics and dashboard works. So yeah, that's it, guys. So let's take like some of the questions. I think that's all about this session. In the interest of time, I tried to keep it a little short.
All right. Hey Ashish.
Hey, Raghav, welcome
Hey,
back.
let me first start off by saying that that was a great session from your side, and I am pretty sure that our users are pretty much very motivated to learn from you. So that was a great session and very informative, I must say.
Thank you, Raghav, and hope
Exactly.
like others also has liked it.
Yes, I believe that we have received great feedback and some great questions from our users. So I think
Mhm.
now is the time to tackle those questions, right?
Yep.
All right. So the first question is from Mr. Siddharth Mehta,
Mhm.
and he says how to approach a system correctly, which is proprietary to a company and is not covered in any system studied as part of preparation.
So whenever actually you are talking about a system which is proprietary to your company, and you are not allowed to disclose the details of it, be sure you should never talk about whichever are the secrets, because it is a industry, and industry works like that. And secrets, if you are revealing to someone, like it may be like damaging like companies, whatever the secrets are there. So you should be very careful whenever you are talking about any system. Be sure like it's not any kind of a secret for the company.
All right. So again, viewers, I would like to remind you that if you have any question or query, please submit it in the form given in the description, and we will try to answer your questions right now. Right. So the next question is from an experienced user, that is design pattern also required for an software development role for
Yeah.
a person who has 9 years of experience.
Yes, for SDET also, like it's certainly required, because when you are doing a testing, right? So as a senior, it's not like you'll be testing one component, right? You have
Mhm.
to like prepare some kind of test plan, like what are the things that you'll have to test, right? So when you're preparing test plan, certainly you need to dig into like a lot of different components. So you
Okay.
should be aware of like what are the components that could be. Certainly it is required.
All right, that's a great answer, Ashish. So the next question we have is from Mr. Saurabh, that how different is system design from object-oriented design, and also how much emphasis is given to design patterns in these interviews.
Yeah, so there are actually we divide the design problems into two parts basically. One is the high level design and one is the low level design. And here also what we say is like as a part of high level
All
design,
right,
in general, I'm saying in general are like highly available and highly scalable systems, which are like a Facebook, Twitter, these kind of things. But when we talk about like a low level design, they are mostly like object oriented, like design chess, or like maybe like design some kind of a library system, online library, or like these like small object oriented design. These comes as a part of low level design. Now coming to this
all
design patterns. So design patterns, you may be applying in the high level design as well. Let's say like you have to observe like some of the a response from the API that you're calling. So there actually maybe like you're applying some observer pattern. So design patterns are certainly like they are the building blocks. So you must be like very good in design patterns. It will apply to low level as well as the high level.
All right, I am pretty sure that answers that question. So the next question we have is from Mr. Satyajit. That can you please give some information about some job opportunities company wise regarding the topic of system design?
Yeah, so it's not company wise. I would say like for any company, if you are applying for a senior role, so that's where meaning like they are looking for some kind of leaders, right? So being a
Right.
leader, you should be aware of the things in breadth, right? That's where comes the system design. So if you're applying for a senior position, certainly you need system design, and you'll have to pass through that system design interview.
All right. So the next question we have is actually from your alma mater, Jadavpur University's.
Mm-hmm.
Mr. Jaydeep is asking that is it necessary to learn system design at this level? He is in second year currently, or should he learn about it in his future?
At this, like certainly, it's not required like that you should go for system design, but certainly like when you are doing a project, you are designing, building some system, right? You are already exposed to some kind of systems. So you
Exactly.
must like try to see like how that system is. It's not like that you design a Facebook. It's not like that. But whatever the system by the part of project that you're doing, see the details like how exactly that system is working, how actually you're coming up to approach, right? So that's how
Mm,
actually it works.
all right. So another question that we have is that how much time should an individual take after the
Mhm.
interviewer asks the question? That
Yeah.
what should be the appropriate time?
So how much time should take just after interview? So it's not like that taking time. So that's how actually when I said about the communication has to be really great.
All
Your
right.
session has to be very very interactive. It's not like then you are completely silent. And at this point like it's like more important to be more communicative, because in a virtual it's like even more difficult for interviewer to understand what actually if you are writing something on copy and pen. I don't know like what actually you are writing, right? So the session
Right.
has to be very interactive from the beginning, and what are the thought process that is coming to your mind, it has to be clearly delivered to the interviewer, so that like if you are like maybe like completely going in a wrong direction, he should be able to
Right.
know. Otherwise, like if you're silent, I don't know like what actually you're thinking. So begin from the very beginning, make it more interactive, start from the beginning.
Exactly. Exactly. Great advice, Ashish. Great advice. All right. So that was it from the. That was it. And any more questions,
Yeah, so
users?
one thing actually I wanted to add, as I said, like how a Facebook interview looks like, that was actually a bonus. So
Okay.
I so uh, the first thing starts is you are getting a call from a recruiter. Like you will hear, hey, how are you doing? It's a recruiter from Facebook, and you will be surprised. Okay, you got a call from Facebook. That's really amazing. Like getting from the FAANG company, it's really always surprising, right? Now
Exactly.
they are like they will treat you like so well, and the way they will be explaining the details of each and everything, the role, the kind of work, and what are the expectation, everything they will be explaining you in detail. Like maybe they will be taking 30 minutes of you to and for that also, it's not like they will be calling and they will say, okay, can we discuss? They will tell you, okay, can you please book tell us some slots so that we can discuss about this role. And
All
it's
right.
up to like it's quite flexible. And then once
All
you book the slot, they will give you like a lot of details. They will send a lot of documents after that. You prepare through it. Then comes the bomb. You have the phone screen. There may be like phone screen. It's not like difficult, I must say. Like they may be like medium to easy, but some interviewer may be like very rude. They kind of different kind of, they may be asking hard also, but it's like not expected. And
right.
if you pass that phone screen, it may happen that you did really well, then they will directly invite you for on-site. Or if you did like there is some kind of confusion, they may be like, okay, one more phone screen. And then if you clear that phone screen, then you are into the on-site. And once you
All
are in the on-site, you have like a too much of grilling rounds. The bar
right.
of the on-site are going to be like way higher than the phone screen.
Mhm.
And for each round, either phone screen or on-site, there are going to be two questions. And for each question, be sure you have to like entire session has to be very very much interactive. It's not like that, okay, you are writing something and I don't know like what you are doing. It has to be very
Mhm.
very interactive. Communication has to be great. They want to see your problem solving skill. They want to see like how actually you're coding. So be sure you'll have to write completely flawless code for both the question, and also like you'll have to come up with the most optimal solution.
All
And
right.
you can expect like 2 to 3 like problem solving. It depends again from level to level. So
Okay.
2 to 3 problem solving data structure rounds. And for the senior, there may be like either system design or maybe a product design round. So it depends like which is your current role. Based on that, they will come up with system design or product design. So
Oh,
there also it may be like 1 or 2 rounds. And then if you clear those rounds, then you get a call. Okay, hey, congratulations, you're welcome to Facebook.
all
So
right.
so that's how actually it looks like. It's like quite a great experience. So that's all.
Okay. Yeah, I am sure many of our viewers are waiting for that call, right? So that was great experience, great knowledge from you, Ashish. So yeah, do you have anything else that you want to add? Any other advice that you might want to give out?
Yeah, advice is like for learning system design is like a daily work. It's a, whenever there is a kind of a tech talk, try to attend those tech talks. You'll learn a lot of things from the tech talk itself.
Right,
Try to
right,
understand the system that you are working in. That will give you like a lot of details how exactly you are going to design your new system. And
all
try to
right.
learn about not just the system, also like how exactly you are shipping the product. That will also give you the details of how exactly the metrics and dashboards those actually looks like, and what are the preparation that you do as a part of shipping a product. So that's the
Right.
advice. Like be sure like whatever you're working on, you should give more focus and try to get more details out of it. Yep.
All right, great. So again, viewers, if you would want to connect with Ashish, we have included his LinkedIn profile in the description below. So if you have any questions or doubt, please connect with him on LinkedIn. Right. So again, thank you so much, Ashish, for being with us today and joining us today and sharing your immense knowledge with all of our viewers out there. So thank you so much again.
Thanks, Raghav. It was, and thanks to Geeks and our viewers. It was really amazing session and loved each and every bit of it. It was really amazing. Thank you, guys.
Right.
It was awesome. See you next time. Okay. Bye
Sure.
bye.
Thank you.